Hi, my name is Yue, and my project is on sentence embeddings of dictionary definitions for sense-aware word vectors. To motivate creating sense-aware word vectors, I'll draw attention to this phenomenon of word polysemy. Take a word like run. It has many different meanings, for example, that of exercising, what a presidential candidate might do to get elected, the sense related to the execution of a program, also this tear you can get in your stockings, among many others. And this phenomenon is not something that strikes words incidentally, but is actually quite pervasive across the entire lexicon and all four parts of speech. Unfortunately, most VSMs provide only a single representation for a given word form and does not take polysemy into account, and the success of this assumption might also be overstated due to the fact that most evaluation metrics in the form of word similarity datasets elicit human judgments by giving them these words out of context. Previous work that's been done to try to address this problem of creating sense-aware word vectors are both supervised and unsupervised. I'll highlight a few among each. Jahar et al. Proposed two methods. One is to retrofit a VSM onto an existing ontology. Another is adapted maximum likelihood estimation using additional latent variables that represent specific word senses. Ettinger et al. Used the intuition that the English word run that we just saw, those four senses are probably expressed using different words in another language, and thus they derive a sense graph based on bilingual parallel text corpora, and the advantage is that human-created sense ontologies might have certain biases. And then among unsupervised approaches, there's work by Huang et al. From 2012, where they first perform word sense disambiguation and then train embeddings on the newly sense disambiguated forms. Another contribution of theirs is creating the Stanford contextual word similarities dataset, which is similar to other word similarity datasets, except for humans are given a paragraph of context. And also Neela-Kanta et al., which is an improvement over Huang et al. Both in computational efficiency and in the vector representation. They take an online approach where the learning of the sense-aware vectors and the mapping of words to sense clusters is done jointly. And this also allows the number of clusters to be variable rather than fixed. The approach that I'm going to advance here in this project is to represent word senses as the sentence embeddings of their dictionary definitions, using the sentence embedding approach in Aurora et al. 2015, which is a weighted average of words in the sentence with some additional PCA and SVD post-processing. There are some advantages to this approach. Firstly, this leverages a huge body of supervised annotation in the form of dictionary definitions, and is also essential for longitudinal studies in linguistics and NLU, because polysemy is not a static characteristic, but is rather something that changes dynamically over time. And dictionaries have access to this kind of temporal information by providing time-stamped dates associated to particular senses, whereas ontologies and corpora tend to be too sparse beyond the most recent 100 to 150 years. And for my data, I'm going to be taking the top 6,000 most frequent non-stop words from the British National Corpus as a word set, and using the historical thesaurus of English as the source of definitions. And here's an example of the partial entry for the word rock. And here are some baselines for my sentence embeddings: naive sum, naive average, and weighted average. And for all of the sentence embeddings, I use the Google News vector embeddings. My evaluation tasks are, first of all, word similarity datasets, which are only applicable to words that have a single sense. And I use this as a way of assessing the sentence embedding approach of dictionary definitions as a way of representing word meanings in the first place. Also the Stanford contextual word similarities dataset, and then finally a WordNet-based word sense disambiguation task where I compare the nearest neighbors that are based on the cosine distance in the sentence embedding VSM to what I'm taking as the gold standard which is the WordNet sense set of the disambiguated word sense. So here are the results of word similarity applied to words with a single sense using the 3 different baselines and over 3 different word similarity data sets. Unsurprisingly, naive sum is very poor. Weighted average is slightly better than naive average across all 3 data sets, and looks to be reasonably well correlated with the word similarities. So sentence embeddings of dictionary definitions looks like a solid way to go. And for the WordNet WSD task, first let's look at this example to make things a bit more concrete. So if we take the word pig and the meaning of a slovenly person, the definition from the historical thesaurus is offensive or slovenly thing/person. The WordNet sense set of this disambiguated sense has the words slob, sloven, and slovenly person. Given the definition, I can then create a sentence embedding using the various methods and the nearest neighbors according to the Aurora et al. Method is slub, sloven, and bacon. And finally, you can also look at the nearest neighbors just using single representation word vectors. And the nearest neighbors returned by that method and that VSM are hog, bacon, and pork. And I can then compare the respective F1 scores of each of the blue boxes to the red box. And here are the results. So the Aurora et al. Sentence embedding method has the highest F1 score, and the Google News single representation VSM has a very poor F1 score, even worse than naive sum. So to conclude, I've proposed a novel supervised method for creating sense-aware vectors, and it's a considerable improvement over single sense vectors on the WordNet word sense disambiguation task. For the rest of this project, I'll be doing that Stanford contextual word similarities evaluation, and also looking into improving sentence embeddings by being more discriminating in how you remove stop words. So certain prepositional phrases involved in the dictionary definitions, such as instead of or due to, make significant contributions to a word's meaning and could be incorporated as phrase vectors in the final sentence embedding. And also I'll be experimenting more with different hyperparameters in the word vector settings. Thank you very much.